Ultrasound Training Institute. Today we will discuss about ultrasound. Ultrasound, how it passes through the body. Now there is a technique which is called as pulse echo technique. By this pulse echo technique, we are able to generate an image of ultrasound. Now an ultrasound machine calculates the distance from the probe to the tissue and time of each echo returned, and machine displayed the distance and the intensity of the echo on the screen, forming a 2D image. So this way the machine is calculating when I have sent, when I have received, how much I have sent and how much I have received. That way it is generating an image on ultrasound. Now in ultrasound, what is happening? First, the ultrasound machine transmits high frequency sound pulses into the body using the probe. That is one. Second, the sound waves traveling into the body and hits a boundary between tissue, for example between a fluid and a soft tissue and bones. Third, some of the ultrasound waves are reflecting back to the probe while some travel further deep into the body. Fourth, the reflected waves are detected by the probe and relayed onto the ultrasound monitor. Fifth, the machine calculates the distance from the probe to tissue or organ using a speed of sound in tissue, and that is 1550 meters per second. And the time of each echo return, and it is usually in the order of millionth of a second. And sixth and lastly, the machine displays the distance and intensity of the echo on the screen, forming a 2D ultrasound image like this. So this is the sequence how the machine is working. So summing up, first, what we are doing, we are sending the wave into the body, and from this point it is reflecting back. The machine is calculating when I have sent and when I am receiving, and how much I have sent and how much I am receiving back. That way the monitor is reflecting us an image of a given area or an organ. So in one line, it is a pulse echo technique where we are sending something and we are receiving back. That is the pulse echo technique. This is the technique on which ultrasound is working. Now we are having different probes. The main difference between these probes is the frequency. In some probes, like in TVS probe, we are having high frequency, maybe more than 8 megahertz. Sometimes it is touching about more than 10 even. But when I say a convex probe, in convex probe I am having a low frequency as compared to a TVS probe. So in a convex probe we are having low frequency because the lower the frequency, more it will penetrate in, but the resolution will be less. But when I am using a high frequency probe, I am using whenever I am using high frequency, I am not penetrating, but resolution is more. So whenever I need penetration, I will be going for the convex probe. Whenever I need resolution, I have to shift to a high frequency probe. Now in this probe, there is something which is called as a piezoelectric crystal. This piezoelectric crystal is sending actually all ultrasound waves in the body. And just now we talked about the frequency. The frequency will be deciding by the thickness of this piezoelectric crystal. If the piezoelectric crystal thickness is more, the frequency will be less. and if it is thin, the frequency will be high. So the frequency of a given probe is decided by the thickness of the piezoelectric crystal. If the piezoelectric crystal is thick, the frequency will be low. So in this ultrasound probe, I am having this piezoelectric crystal which is over here. This is the piezoelectric crystal. Then I am having a baking material over here. So this is overall this probe what we are using. So main two components is over. Main is the piezoelectric crystal backed by the backing material which is over here. So this way the ultrasound is generating an image onto the monitor, and this way the ultrasound works. Thank you very much.